All right, this is my solution to getting started with test-driven development. The challenge is to write a fully tested library of units converters. I'm going to create a project with a library of units conversion functions that could be useful to, say, a physicist, a chemist, or an engineer. Project should have two main code files: the library itself. I'm going to call mine converters.py or converters.js, depending on which language I'm in. And the tests are going to be in a file called converters_test.py for Python and converters.spec.js for the JavaScript one. Going to use my miles per gallon to kilometers per liter function sort of as inspiration. That was the last project we did. Going to make sure I can run my tests from the command line, and I'm also going to practice using linters in my code. Since the library is small, I'm going to shoot for 100% coverage, and as a bonus, I'm going to try to configure my repo to use Travis CI to automatically upload and run the tests in my project when I get done. Okay, the first step before you get started programming should always be to do some planning, right? You got to think about what conversions you plan to include. In this case, I said have 3 or 4, so I'm just going to have 2 different categories, and I'm going to do the conversion in both directions. So the first one I thought I would choose is fuel economy. And one of the things I thought was interesting when I started researching this is that in the US, we typically refer to miles per gallon, focusing on the distance you travel on, say, a gallon of gas, whereas in Europe, it's measured in liters per 100 kilometers, which focuses on the amount of fuel used more and standardizes the distance of travel. So I'm going to have one function that does miles per gallon to liters per 100 kilometers, and then I'm going to have a liters per 100 kilometers converted into miles per gallon function to there. And then I'm going to do some pressure conversions, converting imperial units to international units and vice versa, right? So PSI to kPa. PSI is pounds per square inch, more accurately, pound force units per square inch, and to kilopascals, which 1 Pascal is equal to 1 Newton per meter squared, right? And a Newton is a unit of force. Looked up some useful constants in this case: the kilometers per mile, miles per kilometer, liters per gallon, gallons per liter, newtons per unit of pound force per newton, and meters squared per inch squared, and inch squared per meter squared, right? So I got those in both directions because I thought they would be useful. Next step is to do some calculations by hand, right? Eventually we're going to write automated tests, and we're going to use these sample calculations as the content for our tests. So it's important that you pick realistic numbers, because one of the ways a computer program can go wrong is when people put unrealistic inputs into it, right? Realistically, nobody's going to be doing calculations with 10 billion pounds per square inch in them. So we wouldn't want to test with a number like that, although computers don't care about the scale so much. But those extreme values might cause problems, but we want to do tests with stuff that's realistic. So for example, a car tire generally has a pressure of 32 to 35 pounds per square inch. Plug that into the formula, cancel out all the units, and we get 32 psi is equal to 220.632 kilopascals. Checked out with Google, and that answer was correct. Average atmospheric pressure at sea level is approximately 101.325 kilopascals. Plug that into the formula, and I ended up with my calculator getting 14.6959525 pounds per square inch. Again, the Google confirmed that was correct. A car that gets good gas mileage in the United States gets 40 miles to the gallon. So in this case, since the answer is in liters per 100 kilometers, and the relationship is inverted, right? In US units, miles per gallon puts the miles on top, and in the European units, liters per 100 kilometers puts the volume of fuel on top. So the first thing I had to do was invert the miles per gallon and say 1/40th. So 40 miles per gallon is 1/40th of a gallon per mile. Multiply that times miles per kilometers, and all the rest of this, and I ended up with 5.88 liters per 100 kilometers. And that's the equivalent of 40 miles per gallon. And then I looked up some numbers from the International Energy Association. This is one of the international organizations that is most trusted for doing the science on things like fuel consumption. They also track things like the Paris Accords and how well countries are keeping up with their commitments to make improvements to not have climate change be so bad. And so I found out that in 2018, United States fuel consumption actually improved by 0.8% to 9.4 liters per 100 kilometers. When you plug that into the equation, that's actually only 25 or so miles per gallon. Meanwhile, in the same year, 2018, European Union consumption worsened to 5.1 liters per 100 kilometers. When you plug that in, it's 46 miles per gallon. So basically, in other words, in 2018, Europe was close to 80% better than the United States, and their value had gotten worse from the previous year, and our value had gotten better. So the difference was even more stark in years before that. But checked all my numbers, rechecked the math, made sure it's all correct. I've got the equations that I'm going to need, and so this is really useful. If you can avoid having to think about the actual math problem that you're trying to solve, or whatever human problem that you're trying to solve, and you're programming at the same time, you'll make things easier on yourself, right? Don't make it overcomplicated and try to think about all this math at the same time that you're trying to figure out how to write a program. Things will just get really messy at that point. And then before I get started, I want to anticipate some issues. So as I was doing these sample calculations, I began to think about well, do the functions need to append unit labels like miles per gallon or liters per 100 kilometers? And my answer to this question is probably not. We're going to put these calculations out there, these conversion functions out there as a library. Whoever is using the library will know which functions they're using, and they can add the units on after they get the output back, right? And, in the case that they're using the results of these calculations as the inputs to maybe some other calculations, then it would be annoying for them to have to strip off any units that I maybe attach to them. So not going to append units here. Second question that came up is, well, then how precise should the answers be? Should I round the output? And the problem here is you don't know how much precision the person who will be using your equations is going to need, right? If somebody's doing this for something like an online calculator or something like that, probably they don't need a huge number of decimal places. But if they're doing science and they want to be as precise as possible, if you round these values before you send it back to them, that could hurt the work that they're doing. So I'm going to go with no. If somebody really wants a rounded value, they can round it afterwards. And so the last question then, caused by that second question, was if I'm not rounding the numbers, how do I know what to test against, right? If I, if I create one of these functions and it gives me an answer with 12 decimal places, and in my test, I'm only testing against, 8 decimal places, my test results and the expected results might not line up. And even though my math is right and the calculation appears to be right, it might indicate that it's wrong And so what I decided here is I'll follow my advice from number 2, and I will just round the results that are coming back from my functions in the actual test itself and compare against that value. That way I don't have to worry about typing out a whole bunch of significant digits in my tests. So let's get started with the Python version of this project. I'm going to go to my slide deck on slides.com, slides.com/morphatic, how to start a new project, and I'm going to jump down to the Python version just to follow these steps. Create a GitHub repo with a python.gitignore, clone the repo to my hard drive, initialize a virtual environment to use the right version of Python, and then I'm going to do this slightly differently this time. I think once I've created the virtual environment, then I'm going to open up VS Code and use the terminal within Visual Studio Code to do the rest of the steps. But first off, let's create a new repository. Click on the plus sign, select new repository. I'm going to call it converters-tdd-python, a units converter library demonstrating TDD with Python. Click the box to check add a README, click the box to add a gitignore, and from the drop down we'll type Python, select Python, click create. Then I'm going to click the green button, click the clipboard icon to copy this URL. Then for my terminal, I'm going to cd into my dev folder and git clone the repository that I just created, cd into that directory, and now I'm going to, as you can see here, I'm in a Git repo. Now I'm going to open up Visual Studio Code. And maximize it. Okay, and open up my terminal. And from here, I'm going to initialize a virtual environment. To do that, I'm going to type python 3-m-venv. That will create the virtual environment directory. Then I'm going to activate it. Okay, now that that's activated, I can begin to install the packages that I'm going to want to use for doing test-driven development. I'm also going to install Pylint for using linting, and in addition to PyTest, there's a few other packages that I'm going to show you how to use today. Those are PyTest testmon, PyTest describe, and PyTest watch. Some of these I'm going to use because they add additional functionality, and some of them just because they allow me to write my tests in a style I'm more comfortable with. So you see here pip install PyTest, PyTest testmon, PyTest describe, and PyTest watch, and I'm going to add onto that Pylint. Okay, so now that those are done, I'm going to check out this warning here that says I'm using a slightly out-of-date version of pip, and to get it, it says I should type python-m pip install --upgrade pip. This is not 100% necessary, but in general, when the command line tells you to do something, I try to follow it just to be on the safe side. Okay, so the next thing I'm going to do is I'm going to create a new file called pytest.ini. Now, pytest.ini is not strictly necessary, but if you want to tweak the settings that PyTest uses, this is a file you can create. Now, if you want to know what other sorts of ways you can tweak the settings, you can you can Google pytest.ini documentation, and you can get the configuration documentation for pytest. And this file has a special file name, pytest.ini, which pytest will look for when it starts up. If it finds it, then it will look inside of it to check to see if there are any special settings that it needs or that it wants to use. I've done a little bit of research in this, which is how I know which settings I want to use here. In fact, I'm copying and pasting these settings from another project that I did in the past. I'm going to just paste these right in here. And this first one, this is a pytest setting that will ignore deprecation warnings. What I found before was that when I was in the middle of a project, Python or pytest upgraded, and then one of the packages like pytest describe that I was using didn't upgrade, and it was causing some warnings to pop up every time I ran the test, and it was more annoying than anything else. But just to prevent those from happening, I'm filtering out deprecation warnings from my pytest results. Then for the pytest watch package that I installed, I'm setting test monitoring to true. I'm telling it to clear the terminal after or before it begins each test run, telling it to be quiet so that it doesn't output verbose information, and also not to cause the computer to beep every time it runs. So I'm going to go ahead and save that file, and you can see that when I do this, the editor turns the file name green and puts a U for untracked. It means that's a new file that GitHub or that Git just learned about but is not tracking yet. All right, so let's see how we can set up linting. I'm going to do Shift Command P to bring up the command window here, and I'm going to type pylint, and you're going to see here Python run linting, Python select linter. So I'm going to do that, and it's going to give me a choice. I'm going to select pylint, which is the one that I have. Now a message just popped up that says no test discovered. Please check the configuration settings for the tests. This is the source of this message is the Python extension that's installed, and we have just created the pytest.ini, and it's already looking for tests, but we haven't created any yet. So this is fine. I'm just going to X out of that notification. All right, so we've got linting turned on, and let's just double make sure, because there was another selection down there, Python enable linting. Let's type pylint just to make sure we get the right one. Enable linting. We selected a linter, and it says it's currently on. That's good. That's what we want. All right, so linting is on. We've installed our testing framework, and we've tweaked some configuration settings. The next thing that we want to do, let's go back to our list of instructions, is we want to do this command, pip freeze, and we want to output the results of pip freeze into a text file called requirements.txt. Now what this does is it just makes a list of all of the packages that we've installed so far, and it writes it to a file called requirements.txt. If we look inside of that, you'll see that there are 24 packages that are installed here. They're installed locally inside of the VN folder. Now we won't upload the contents of the VN folder to GitHub, but if someone else wants to clone our repository and run the program with the same versions of all of these packages, then this will be documented here in this requirements.txt file. And there's a pip command where you can run pip and ingest the contents of a text file. So instead of doing pip install and typing all of the different package file names or package names, they could just do pip install and then tell it to read the stuff out of requirements.txt. That makes it easy for you or someone else to completely recreate the coding environment that we have here on their own computer. All right, so that's what I did. That's why I did the pip freeze. This is why I did pytest.ini, and then it doesn't say so on this list, but if you go back one slide here, it says set up TD tools and write and run a smoke test. So let's write our smoke test before we do anything else. Now I'm gonna close out of the pytest.ini file. I don't need that one anymore. And I'm gonna create a new file, and we're gonna store it in the root directory, and I'm gonna call it converters_test.py. Now the name I've chosen here is significant. _test.py signals to PyTest that this file contains tests. It's a special naming convention. You can call it whatever you want as long as you end it with _test.py. Now you can make it test underscore and then anything .py, but I prefer to put the _test at the end. And the reason I call it converters_test, right, converters test, is because we're gonna create our units converters in another file that we're gonna call converters.py. And so you've got converters.py and converters_test.py. And those two files, clearly they have similar names, and one is clearly gonna contain the tests for the other one, and that's why I chose this particular naming convention. So creating the test file first, right? Because this is test-driven development, right? That means we need to start by creating a failing test and running it to watch it fail. And actually, even before we run our first failing test, we're gonna run a special test called a smoke test. Okay, so one of those packages that I installed was called pytest describe. And pytest describe is a package that allows you, it's a plugin for PyTest that allows tests to be written in arbitrary nested describe blocks. This is following a convention or a best practice from the Ruby and the JavaScript community. And I'm used to writing my tests in this format, and that's the way I think about them. And so I'd like to keep that same style in my Python files. And it allows me to have a nested testing structure. So I start at the outer level with what is typically referred to as a test suite, and using the describe underscore keyword at the beginning. And then inside of it, all of the functions that inside of here, I can name them whatever I want, but they will then be the tests. And if you name your tests well, then it forms a sentence. For example, describe append adds to end of list. That is a nice, flowing, easy to read, even if you're not a programmer, easy to understand structure for structuring your tests. So that's why I use pytest describe. It's not probably the most common thing in the Python community, but it's also not unheard of, obviously. So let's go in here, and I'm going to type def to define a suite of tests, and I'm going to start with the describe keyword, describe underscore library of units converters. And because it's I used def as the keyword here, that means it's a function, and so I need to end it with parentheses and a colon. And now I need to write my smoke test. So I'm going to say def blows smoke. All right, and inside of here, I'm going to assert true. Basically, assert true says that true should be true. This test should always pass. And the purpose of a smoke test is not to test any code, but only to determine that your testing environment is set up correctly. So let me save this file. Okay, now as soon as I do that, you'll notice that I start getting some squiggly lines underneath my code. There's some blue ones and there are some yellow ones. Those are put there by Pylint. If you mouse over them, you can see here Pylint is saying I'm missing a module docstring. So this is a style convention, a style rule that Pylint tries to enforce. And the rule here is that every module or file should have what's known as a doc string. It's basically something at the beginning of the file it's a comment at the beginning of the file that describes what's in the file, right? It's a good practice because it helps people understand what's in your code. So that means we need to add that module docstring at the beginning here. So I'm gonna go up here, and by convention, you should use the triple quotes, multi-line comment style, and we're gonna just say what this file contains, right? Unit tests for the units converter library functions, and end that with 3 double quotes. All right, and now you see here I still got some squigglies. If I save this, the PyTest will update its or Pylint will update its warnings and recommendations when you save, right? So I've got it to lint on save. Now I still got a blue squiggly here, but now there's only 1 warning instead of 2. It says missing function or method docstring, right? So another rule for Pylint is that every function should have a docstring or some sort of documentation, right? So this is a function, and therefore it should also have a docstring. And in this case, it is test suite for units conversion functions. And I realize that this is a little bit redundant given that I said something similar up here, but in real life there's probably going to be a little bit more variety or variation inside of your functions, and so you'll be able to say substantially different things here, or not. I mean, even if you are repeating things, that'll still be useful to the people who read your documentation. So let's save, and great, our blue squiggly line went away from here. No more blue squigglies. Now all we got left is yellow squiggly lines, and if we mouse over that, it says bad indentation. Found 2 spaces, expected 4, right? I've got Visual Studio Code set to automatically only indent 2 spaces instead of 4 spaces. That's because in my JavaScript code, I'm used to doing 2 spaces. That's my preference. Pylint uses the PEP 8 standard. Remember, if you want to know what the PEP 8 standard is, just Google PEP 8. Right. PEP stands for Python Enhancement Proposal, and Python Enhancement Proposal 8, or PEP 8, is a style guide for Python code, and it goes through and it lists all the rules and explains what they are. Highly recommend that you come through and read through this document. It's super interesting. Well, super interesting if you are anal about formatting like I am, but this will really help you understand the way that programmers think about formatting code. So it's a good window inside the brains of computer programmers, and you might read that and like, oh my gosh, I can't believe how anal these people are, and it's true. But that kind of attention to detail and care is what results in high quality software being written that solves amazing problems in the world today. So I'm okay with that label. So it's telling me that I've got a problem because I'm only using 2 spaces for indentation instead of 4. There's an easy way to fix that. Down here at the bottom of the screen in the status bar where it says spaces 2, I can click there and I can say click indent using spaces and then select 4. And so I'm going to take those few lines and indent them, and then I'm going to take these, oops, and then I'm going to take these 2 lines and indent them. Is that right? No. This line down here needs to be indented. 1, 2, 3, 4. Okay, so 4 spaces to this level of indent, 4 spaces to this level of indent. I'm going to save the file. Still getting a couple of squigglies. This one says unused variable blows smoke. All right, so Pylint, one of the rules is if you create something, a variable, a function name, that it should be used. In this case, there is no place that it's going to be used, and therefore we have an option, which is to tell Pylint to ignore it. You should only tell Pylint to ignore stuff when you know for sure that it's not going to cause a problem to ignore it. So I'm going to look up, like I said, programmers don't memorize stuff, and off the top of my head, I don't remember the syntax that you use to tell Pylint to ignore something. So Google Pylint ignore. Is it possible to ignore one single specific line with Pylint? And yes, here you go. This is how you do it. You use a comment, Pylint disable equals, this says in this case, this ignores the no member, right? And I'm going to put it up here and say Pylint disable, let's see, what was the thing I wanted to disable? Unused variable. Let's see, disable equals unused variable. Disable equals unused variable. Make sure I spelled it correctly. Now let's save that. Okay, so now that yellow squiggly went away because we told Pylint to disable unused variable, and it'll just disable it in this context. And then this other one says my final new line is missing. One of the other style rules in Python or Pylint PEP 8 is that they want you to have one empty line at the end of your file. So I'm going to save that, and what do you know? I've used Pylint to make sure all of my code is nice and prettily formatted. And this is the reason that we use linters. It's because they force us to learn the style that other programmers use, so that when other programmers look at our code, they'll feel comfortable, they'll be able to understand it quickly, and they'll be able to focus on what our code does and not how it's formatted. All right, so now we want to run our smoke test. So there's several ways to do that. One way is we can type pytest at the command line, and you can see here that it says no tests ran in 0.01 seconds. That's not what I expected. Okay, I figured out why Visual Studio Code's terminal was not finding the correct version of pytest. I fixed it. Now I can run my test by typing pytest at the command line, and you can see Python version 3.8.5, and it's using the local one. And you can see here I get a green, one test passed. So my smoke test right here is doing exactly what it's supposed to. This dot right here is a dot indicating one successful test. If I had 2 successful tests, there would be 2 dots. If I had 3 successful tests, there would be 3 dots. So 1 dot for each successful test. looks kind of like a period in the current location, but that's not actually what it is. All right, so we have successfully configured our testing environment. We've successfully configured linting. It's a good idea to take a snapshot of this and push our results up to GitHub. So I'm going to check the status of my project by typing git status. And it says I've got this folder called VS Code. Now VS Code, these are Visual Studio Code related settings. If you want to share VS Code settings across developers or across projects, then it's okay to keep this in here. I think in general though, people tend to leave it out, and I'm going to follow the best practice and just leave it out. The way that you get Git to ignore stuff that you don't want it to check into the repository is by going to the git ignore file. And I'm going to go scroll down to the bottom, and I'm going to add VS Code settings and put .vs code into the list of things that Git should be ignoring. And now if I run git status, now it says that I have a modified git ignore, but VS Code, right, which was up here listed as an untracked thing, is now no longer in the list. And you can see that it's changed from green to being grayed out. All right, so converters test, pytest.ini, requirements.txt, all of these things I want to commit all these things. So I need to add them to the list of things that are being tracked. Git add dot. When I do that, you can see that the use for untracked changed to added. If I check my git status again, you can see that all 4 of the things are now ready to be committed. So I'm going to do git commit-m, type a useful and memorable commit message. I'm going to just type pytest ini for initialized or configured, pylint, okay. All right, so that means pytest and pylint are both installed. I could even put smoke okay, right? Which means I created a smoke test and ran it and it all works great. So once I commit that, you'll notice that the colors change up here because now, if I do git status, I am on the branch master. I'm 1 commit ahead of my remote GitHub repository, but nothing to commit. Working tree is clean. That means there are no files that have been edited since the last time I committed my code. So I'm going to do git push to push those things up to GitHub. And now I can get started with confidence. So I'm going to go back and look at our process. So we have, at this point, we have finished the start, right? The starting process for a project involves all the things that we've just done, right? Getting testing test framework installed, getting linting set up, outputting the list of packages to requirements.txt. All of these things are part of this little bubble up here that says start. You should do these things at the beginning of every project, right? That will put you on the right footing to being successful and efficient and effective. And so our next step then is to write a failing test. So let's go to the list of conversions that we plan to do. And let's pick one of the easier ones. In this case, let's pick the PSI to kilopascals, right? And so we need to write a test, a failing test that will test for kilopascals. So describe a library of units converters. We're going to go down here and we're going to type DEF and we're going to define, right? If we read this as a sentence, describe a library of units converters can convert PSI to kPa. So we want to be able to convert PSI to kilopascals. And when we do this, we're going to assert. Now here, we haven't written any conversion code, right? But we need to write a failing test. And so what's going to happen in a bit when we start writing our conversion function library is we're going to create some functions. And we haven't created those functions yet, but now is the time when we can pick a good name, right? So what would be a good name for a function that can convert PSI to KPA? How about PSI to KPA, right? This function name did not exist and until just now when I created it. But this is going to be a function that's going to take in a value, right? A PSI value, and it's going to output a KPA value. Now, we did these calculations here during the planning phase specifically so that we could do these tests, right? And we found out that 32 PSI is equal to approximately 220.632 kilopascals. So in here, we're going to assert that PSI to KPA of 32 is equal to this, right? And we could even put a comment here. Let's go ahead. I'm going to add a blank line at the end and save this. And you can see here we're getting an error message saying PSI to KPA is undefined. Well, of course it's undefined. We haven't defined it yet. And you get this. Actually, we get this warning twice. Once from the Python extension and one from the PyLint extension. But let's add a comment here, which is 32 PSI equals 220.632 kilopascals, right? We're gonna put the units in here just so that it's super clear what is being done. KPA. All right. So the goal here is to write a failing test, right? So you don't know if it's a failing test unless you actually watch it fail. So I'm going to save this. It's going to tell me about those warnings, but I'm going to go down here and I'm going to type PyTest. And here you go. We have a failing test. All this red, that's what we expected, right? When with the test session started and you see converters test.py, you got one dot. That's the successful smoke test. And then we got a red F. Red F is for failure. And here it shows you what the test is that failed. It says describe a library of units converters can convert PSI to KPA. And it tells you here, it shows you where the failing test is, which is this line, right? Assert PSI to KPA 32 equals. So it tells you that the failure is right here. And it tells you what the error is. It's a name error. The name PSI to KPA is not defined. Great, and we expect that because we haven't defined it yet. This is all going according to plan, right? Because we want to write a failing test first. Now we want to write just enough code to make it past, no more, no less. All right, so where is this function supposed to come from? Well, eventually it's going to come from a file called converters.py, but we don't have that file yet. And before we get there, we need to import the functions to be tested. So up at the top of my testing file, if you want to be able to test something, then you need to import it into the file. So we're going to say from converters, which is going to be the name of the file that we use eventually, import PSI to KPA. And I'm going to save that. Now you'll notice something that's interesting here. The warning that we had down here about PSI to KPA being undefined, that went away because now, as far as this function knows, it is defined. We're importing it. But now we've got a new error, which is that it says unresolved import. That basically means it's looking for a file called converters.py, but it can't find one, right? And this is another similar error, right? Unable to import converters. And this is an unresolved import converters. Basically, these two squigglies are saying the same thing, which is we don't know what this converters file is that you're talking about. But let's go ahead and run our test. Now, something you might have noticed is that we're going to have to keep switching down to the terminal, typing PyTest, hit enter, and then watch the results come up every time we do this. And that's fine, it's not a ton of work, but there is a little cool trick we're going to use, which is why I installed PyTest testmon and PyTest watch. Testmon is short for test monitor, and watch means watch the files in your directory for changes. So we're going to use this tool called PyTest watch, and the way that we run it is a command called ptw. We installed ptw when we installed PyTest watch. That's what ptw stands for. And we configured it with that pytest.ini. What's going to happen now is the tests are going to run, and then the computer is going to watch the files in this directory, and if any of them are changed, right? If you save the file with changes, it will automatically run the tests again without us having to do anything. So watch this. I'm going to hit ptw, and you can see here it cleared the screen, it ran the tests, and caused the error that we had before to show up. And let's make a change, right? Let's just comment out this line, for example. And now I'm going to hit Command S to save it, and you'll notice that down at the bottom, right, the tests ran again automatically. It cleared the screen, and then it reran the tests. That is what PyTest watch does, and it's just a convenience. It's something that makes you have to do a little bit less typing when you are working. All right, so I'm going to go back to what we had and examine this error. Import error while importing test module converters in converters test.py. Hint, make sure your modules have valid Python names. Basically what it's saying here is that no module named converters was found, which makes sense, right? Because we haven't created this file. So let's solve this error. I'm going to create a new file in the root directory, and I'm going to call it converters.py. All right, and you can see here that when that new file was created, it ran the tests again, and the error changed. Right before the error was something like can't find a file called converters. Now it found a file called converters, but it says cannot import name PSI to KPA from converters, right? So what it's saying is, yeah, it found the file, but now it can't find the function that it's looking for. So the next thing we could do is write the function. So let's do it. def psi to KPA. And remember that the input for this function is going to be a PSI value. And then it has to return something. I'm not sure what to return just yet, but I know it's going to be a number, so let's just return 0. And I'm going to save that, and it's automatically going to run our test again. Note that we've got some squiggly lines here, right? Pylint is complaining about the format of our code. So let's figure out what the problems are. I'm going to look at the linting problems first, and then I'm going to go back and look at the failures. You'll be amazed at how frequently you might actually resolve some of your test failures just by fixing the style problems in your code. So the first one, same one we had before, is a missing docstring for the module. So I'm going to go up to the top and add a docstring which says something like library of units converters. Okay, and I think there's a rule about whether you need a period or not. I can't remember what it is. Since it's not really a sentence, I'm going to leave that out. All right, going to hit save. Okay, and now it's going to say missing function or method docstring. So here's where we need to write the docstring for this function. And So this is something that describes what this function does. So it takes in a PSI value and converts it to KPA. All right, so now we've got a doc string for here. We'll save that. And now it says unused argument, PSI. All right, so we haven't used the document. We haven't used this. Why don't we just return PSI? That way, that warning will go away. And essentially, the effect would be to just pass the original value back unchanged. That makes that warning go away. And then the last warning is found 2 spaces, expected 4. We know how to fix that problem. We're going to go here. We're going to indent using spaces, and we want it to be 4. And we need these lines to be indented out one more, and save. And now we have one error, which is final new line missing. Okay, good. So we've gotten all of the linting and formatting errors taken care of. This is looking nice and clean again, right? So now we can focus on the problem, which says assert 32 equals 220.632, where 32 equals PSI to KPA of 32, right? So it's running this function, and it's expecting to get 220.632, but instead, what it's getting is 32. Okay, so remember, we need to do the simplest thing that could possibly work, right? We just want to write just barely enough code to make the test pass. Well, in order to make the test pass, it's expecting the number 220.632. So I'm just going to copy that number and paste it right in here. Essentially what this does is it says that no matter what PSI value you put into this function, it's always going to return 220.632. But watch this. When I save this, the test passes. And this is the key, right? You want to write the simplest possible code that can make your test pass. And again, we have, now we're no longer using the PSI, and you can see how linting, right? There's nothing wrong, like this code can still run, right? There's nothing that a compiler would find wrong with this code. But linters check style, and it's bad style to create variables that you never use. And it's usually an indication that you meant to do something that you either haven't done yet or you forgot. So this saying that I've got an unused argument PSI means I need to fix that, right? Because it says I'm supposed to take in a PSI value and convert it to kilopascals. All right, so now we're in sort of familiar territory, right? So we've written just enough code to make it pass. Now we're at the refactor step. And so what we want to do here is we want to edit our code to get it to the point that it does what it's actually supposed to do. So let's go see what it's supposed to do. So we take our PSI value, we multiply it times newtons per pound foot, we multiply it times inches squared per meter squared, and then that gives us pascals, which we need to convert to kilopascals. To do that, we need to divide by 1,000. So let's get these constants, which we researched earlier. Newtons per pound foot and inches squared per meter squared. So newtons per pound force, that's this value here. And we called that NPL earlier. So I'm going to go up here and I'm going to create a section, declare useful constants. And what did we say we want to call that? NPL. NPL equals 4.4822, and this is newtons per pound foot. That's one value. And then the next one we want is inches squared per meter squared. Is that correct? Inches squared per meter squared. Okay, so the inches squared per meter squared value is 1550. So let's copy that I2 PM2. I'm just going to shorten that to IPM. IPM equals 1550, and this is square inches per square meter. All right, so that now we have those two values, and we know that the value that is returned down here should be PSI times NPL times IPM divide by 1000. So this should return our conversion, right? It takes the pounds per square inch, multiplies it times the newtons per pound foot, the inches squared per meter squared, and then divides that value by 1000 to give the kilopascal units. So I'm going to save that. And dang it, why didn't that work, right? It was supposed to, wasn't it? That's the right calculation. Let's take a look at our test to see how it failed. It's asserting that 220.63172 should be equal to 220.632. So the output of our PSI to kPa function when we pass in 32 is 220.6317112. That's the value we want, right? Almost. Computers are stupid. They take everything 100% literally every single time. And if you take it 100% literally, this number and this number are not the same number, right? This one has more precision than this rounded number that we put in our sample calculations that we did here in this in this planning document. So there's a couple of things we can do. We could go into our test, right? And we could, for example, round this value to 3 decimal places. And if you run that, you can see our test passes. And so that'll round this to 3 decimal places. That's a perfectly acceptable solution. Me personally, I don't like to add additional steps in my test because I feel like doing that might add additional sources of potential errors. If I type something incorrectly there, that could be a problem. So I'm gonna get rid of that, and I'm gonna save this. The other thing we could do is we could change our test. Now, some people consider this cheating, right? Why is it cheating? Because we're not making our code we're not making our code do what the test says, we're making our test do what the code says. And this is practical, right? It's easy to be a purist if you're a programmer, but it's not efficient to be a purist if you're a programmer. Take it from me, I'm a purist, and it doesn't serve me well. But here what I'm doing is I think it's okay actually if we change our test to be more precise, right? Let's save that, and now our test passes, right? Because it does the conversion and it changes it. Another way that we can make sure that this is working, right? Because remember, before our function just returned that value. This is what we had before. We just returned a straight up value. And this passes, right? Because it sends the number that we're looking for. However, this only works for this one value, which is 32. Let's add another test, right? For another value. Let's say another PSI value. Let's see. How about average air pressure in basketball? 8.5 PSI. All right, and so let's look up what the 8.5 is, and 8.5. Let's search for PSI to kPa. and put 8.5 in here. And Google says the value should be 58.6054. Notice what happened here. When I clicked over here and copied it, it changed the value on the left-hand side to something that was very, very close, but definitely different than 8.5. This is going to be important later. So let's start out. Let's use this, right? This is average car tire pressure. And this is basketball pressure. And we want to drop that number in here. And this is 8.5, right? 8.5. All right, so now if we save this, our test runs, and all of a sudden it's saying that it's expecting 58.6054, and what it got was 220.631712. Right? That means you can see here that this first test, 30, PSI to KPA 32, that worked just fine. It's the second test when we tried to convert 8.5, where it got the same answer it got for the first one. That's really odd. Actually, it's not really odd because we hard-coded the value for the first test, right? That's why you want to make sure that you're testing thoroughly, right? Adding enough tests in there to cover all your bases. So let's go back to doing the real calculation and save that. And now you can see we have a problem, right? It's not passing. And you can see here we get 58.6052985 is not equal to 58.6054. So on first blush, when you look at this, you think this might be a rounding error. But if you look closer, 60529 rounded becomes 6053. And this value is 6054. So even if we rounded this, they wouldn't be the same thing. That is a cause for concern. And as it turns out, the issue here, right, is that for some reason in this little units converter that Google has built into the browser, you can see here that the values aren't exactly right. So if I grab this one and swap out 8.5, I think we might be closer. Let's try this. Now we get 58.06052.6. It's still not 60. This is still not close to 6054. All right, so I, for the life of me, don't understand how they get 6054 here for this calculation. What we may have just done is expose the fact that Google's units converter is not always the most accurate thing. I'm going to switch back to 8.5 because I don't need that really big long number there. I'm going to save this. And what I'm going to do is I'm going to decide that I'm going to decide to trust my calculations. Now, it's entirely possible that the precision on these constants that I looked up are not exactly right, and maybe I should change those to be more or less precise. But at this point in the game, the goal of this video is for you guys to see test-driven development style. In a real program, you definitely need to track down these problems and figure out what the heck is going on. For this particular example though, I'm going to cheat again, and I'm going to copy the value that was down here, and I'm going to put it in here just like that, and save it, and now our tests pass. All right, so we've written our first function, and we're getting an error. Let's see. Oh, it's just, no, we're not. We're just getting it that it's been modified. Okay. So now both of our files have no linting errors. All of our tests pass, and we have done all the refactoring that I think we need to do, right? Refactoring can be for things like making the code more correct, making it easier to read, better documented, better formatted, more efficient, right? There's all kinds of things you can do with a refactor. But at some point you get to a point when you're, when you're pretty happy with it, right? I'm pretty happy with this function. And so the next step in the process is to go back to writing a new failing test. And so to do that, right, we're going to go back into our converters test underscore pi underscore test.py, and we're going to write a new test. Def can convert kPa to psi. And then we're going to assert. And we're going to go back and look at our test values that we came up with here. 101.325 kPa. And again, we need to come up with a new function name. Since we have one function psi to kPa, let's do kPa to psi for the reverse. Seems logical enough. We're going to say that that's equal to, what value is that going to be? 14 point, a whole bunch of stuff, right? And I'm going to paste that in there. Put a comment to explain that that's, what is that? That is atmospheric pressure at sea level, right? It's going to be kPa to psi, average air pressure at sea level, just so we know what that test is, because it's important to document, right? So that we can make sure that we're using realistic testing values, right? You don't want to use things that are too unrealistic. Here's another great thing that our linter does. Take a look at it. Take a look at this. Unexpected token equals. A single equal sign in Python is an assignment statement. The comparison operator to test for equality is two equal sign. This is a super easy mistake to make, right? People make it all the time. I promise I didn't make that mistake on purpose. It just happened in the result of typing, as a natural result of typing stuff out and talking at the same time. And the linter and the Python extension caught it and warned us about it. That's a great thing to happen. Okay, so this is our test, right? It's going to test to see if we can convert from kilopascals to psi. So let's save that. And we got the problem that kilopascals to psi is not defined. Duh, we haven't defined it yet. So we need to import it from converters. So I'm just going to add it to the list here, kPa to psi. Save that. And it's still going to give us a problem. It can't import name from converters because it's not in there. So let's go in here and let's define it. DEF kPa to psi. And this takes in a kPa value. Now we're learning about these style issues, and we know we need a doc block here. Takes in a kPa value and converts it to psi. So we'll preempt the linter from complaining, and just to start off, let's return the kilopascals just until we figure out what is better to do. I'm going to save that, and now we get a new failure where it's complaining that the values are not the value it's expecting is not the value that it got, right? It expected to get 14.659 whatever. Expected to get that, and it didn't. So let's just copy that and paste that into here. Save it, and our test passes. All right. Now this is the simplest thing that could possibly work. And again, when you do your test-driven note, we wrote a failing test. We watched it fail. And then now we've written just enough code to make it pass. Now that it's passing, we can refactor it to get it to be correct. In this case, we're going to need a couple more constants. We're going to need the pascals per kilopascals. We don't need a constant for that. We know that that's a fixed order of magnitude, right? Or 3 orders of magnitude. But we need pound-foots per Newton, right? LPN, and meters squared per inches squared. MPI. So again, pound-foot per Newton, so LPN, that's this value. And let's go up to the top of our file here and add it. LPN equals this value, and that is the pound force per Newton. And then we also want MPI, meter squared per inch squared, which is this value. Meters squared per inch squared. Okay. And now we can go back down to this function and we can say that we want this value to be kPa. Let's see, up here we divided by 1,000. Down here we need to multiply by 1,000. And then we need to multiply by the two constants that we just brought in, LPN and MPI. And once we've done that, we can save it. And now we're back to getting those precision errors, right? So the value that we were expecting is 14.659525, but what we actually got is considerably much more precise than that. And maybe for the same reason, there's a rounding error somewhere, and yes, we could probably round, but I'm just going to go in and change the value that we're expecting so that the test will pass, right? I'm also going to add another comparison in here just for this sake. And in this case, I think I'll take a value that we had before and try to convert it backwards, right? So if these two functions are the inverse of one another, then passing 32 to here and then the output of that to here should yield us back to the original number. And this is average car tire pressure. And let's save that. And you can see here that it's close, but not quite exact, right? 31.999932479. So it's really, really, really close to 32, but not quite exact. So what I'm going to do is I'm going to grab that number, I'm going to place it in here and save that, and it'll pass. But it's important to remember, right, that the precision of the constants you're using is going to come out here. Now, in all likelihood, whoever's using these functions will round the values that they get before using them in any significant way, but these are the kinds of little itty-bitty errors that contribute to space shuttles exploding and all kinds of other problems happening, right? Because if you don't take care with your significant digits, you can actually get results that are wildly different, or even just different enough to cause significant problems in your science or technology or engineering or whatever it is. And this test-driven development style is one of the ways that you'll be able to catch that. All right, so I'm not going to go through the process of doing the last two functions, but it's basically going to be the same process, right? We're going to write a failing test. We're going to use these values that we calculated in the planning stage to create our failing test. And we're going to use these constants that we looked up. We're going to add those to our file. And eventually, we'll end up with a library of 4 fully tested units conversion functions that we'll be able to, if we wanted, for example, submit to something like PyPI, right? PyPI, pypi.org. This is the Python package index. And anybody in the world who wants to can submit a package to PyPI for other people to download. And there's some formatting and things that you have to formatting conventions that you need to observe to make sure that your package is listed. But anybody who wants to can do it. That's open source. And any of you who want to do this can certainly publish your own package to Pippy. That's something that would look amazing on a resume or to potential employers, is to have published your own package, particularly if it gets popular before you graduate. The last bit of the challenge, the bonus, was to get continuous integration set up with Travis or Circle CI. I feel like this video's already gotten long enough, and so I'm gonna put that part off until another day. But I hope this was useful, and I will see you in the next one. Here there's a link that says this seems to be expecting this to be a test. So what happens if I click this? Run test. Here you can see at the bottom there is a check mark, and this is the Python extension actually running the tests and putting the output right here. But I'm concerned that when I ran it from the command line, that it didn't find my tests. Okay, so I discovered why it wasn't finding my test. It's because when I typed which PyTest, it said it was finding the one in user local bind PyTest and not finding the one in my virtual environment. And that is weird to me because it should find that first. Actually, not exactly sure what the reason for that is. But this is installed globally on my system. This is another one of those reasons why you might want to avoid installing things globally and only installing the packages you need within the specific projects that you're creating. This avoids problems like this one where I ran a test and it was not finding them right up here. Right? It was using PyTest 3.4 instead of PyTest 6.02. It was using Python version 2 instead of Python version 3. That should have been a clue that when I typed PyTest at the command line, it was using the wrong one. This is a classic case of why you use a virtual environment. Now, because I have the virtual environment, I'm not sure why it doesn't find my version first. Probably going to skip this in the video, but I'm going to quickly research this and see if I can figure it out. One thing I could do is echo the path variable. The path variable is the list of directories that my computer uses to search for executable programs. And it looks like the first directory it looks in is dev converters TDD python venv bind, right? And that's actually where my Python is. I mean, that is where my PyTest is. It's in venv bind PyTest. So when I say which PyTest, why doesn't it find that one? If I say which Python, that finds the correct Python. Let's take a look in that venv directory, venv bind. Aha, oh well, there is a PyTest right here. What if I try pi.test? That's an alias. Which pi.test? That also finds the one in user local bind. Huh. I'm gonna Google this. Pi test. Let's see. Global pi test preempts virtual env. Okay, so here we have someone who had my question back in 2016, but they said I installed PyTest into a virtual environment, which is exactly what we did, and I'm running it from that virtual environment, but it's not using the package that I installed in the virtual environment. Instead, it's using the main system package. I can actually run my tests with the right Python and packages, but I want to use PyTest. Inside your environment, you may try python-m pytest. Let's try that. Oops. Python-m pytest. And that works correctly. So let's go back and give this person an upvote. And this person for asking a great question. Here's another reason, and they say we've activated, we've installed, and then they say deactivate and reactivate. The reason is that the path to PyTest is set by source in the activate file only after PyTest is actually installed. Oh, that's another reason. Okay, so we should be able to do deactivate to deactivate, and then source.bm bind activate. Now if I say which PyTest, it gets the right one. Okay, so this is a matter of installing PyTest after the virtual environment has been activated. Then you have to deactivate and reactivate so that your virtual environment can actually find the executable to the package you just installed. That's super confusing. I'll probably leave this out of the video.